Hello, hello. Is that coming through? Got a thumbs up in the front row. I'm going to take that as we're good. I'm going to start a timer. So if I look at my watch, it's because I'm checking my time, not because I'm bored with my own talk. So let's go. So my talk is called Powering Pixels with Scenic. If you haven't heard of Scenic, it's a library that was introduced a couple years ago by Boyd. It's a 2D UI framework. So it's kind of meant primarily for fixed screen devices, so a lot of IoT devices. Jeffrey Lussell did a talk recently where he used it for an external display for like F1 racing sim, which is pretty cool. There was someone, I think his name was Powell, just a few months back, gave a talk where he used it for, he had like sprinklers set up for his lawn and he was using a screen to be able to interact with that and set that up, which is pretty cool. There's lots of different things you can do with it. I thought it would be cool to try and make a game with it. I've never made a game before. I have no idea what I'm doing, so I kind of jumped into it and tried to see what I could do. So Scenic is, the documentation refers to it as having like a 3-layer cake architecture. So your top layer is scene, your scene layer, and this is where you're going to do most of your interacting. So a scene is kind of like you're building an HTML page, like you're building all the layout of what's going to display on the screen, and then that gets put into what's called a graph, which is kind of like your DOM, that gets sent down through the viewport, and then the viewport translates it down to the driver, and the driver knows like the hardware to actually display it on the screen. And then like the reverse action kind of happens when you have events. So like if you're doing like someone hits a keyboard or moves the mouse onto the screen, and then the input kind of gets sent back up from the driver through the viewport to the scene. And they kind of translate back and forth that way. So the scene has no idea what hardware it's on. It doesn't care. It just knows, hey, I want a box here, and I want a circle there, and I want this text. And viewport, send it down to the driver, and it can figure out how to actually display that. So like I said, the scene, it's kind of like building a web page, or it's kind of more like a chunk of HTML code, because usually when you have a scene in Scenic, it's like multiple scenes stacked on top of each other, so it's like different chunks of display code. So you might have like a menu over here and the sidebar over there. And in each of those scenes, you're using primitives to build it. So you have like text primitive, a rectangle, lines, circles, triangles, kind of all those different pieces are primitives that you can use as like your building blocks to build up your display. And then a component is basically just sort of like a fancy scene. A component it's meant for being reusable, so that if you have like a select drop down, it would have like a rectangle, and then maybe if the mouse hovers over it, like it gets like an outline, you click on it, opens a menu, you select one, that gets selected into the state. So a component, it's kind of like this container of both like the UI and the logic and state that will be happening. And it's, you end up reusing those all over the place. And then the final piece is the graph, like I mentioned before, which is like your DOM or the instructions for how the scene is going to be rendered. So I was going to do a quick demo here, but we're running a little bit short, so I'm going to skip that one and do another demo later. So we're going to jump into what it's like building the first screen that I need for my game. So when you start up a game, you have a title screen. It's a real basic scene. It's just going to have a background image, and then it's going to have a little menu where you can select, if I want to do a new game, continue, change the settings, or whatever. So right here we have the init function, which every scene has an init function. On init, we're going to build a graph, and so right now our graph is empty. It's just a basic. It's just building the container to be ready to start adding stuff to it. And you can go and add settings to it, like I'm going to declare that the font size for this graph is 24, and that way any components or scenes that I add to it will use that by default. And then I'm going to go ahead and add that background. So I'll use the rectangle primitive. I'll define the width and the height, 1280 by 800. And then I can actually go ahead and add in, there's a lot of different options, but I'm going to just add in a fill, and you can do RGB, RGBA. You can just do like a red atom as your color. Or here I'm defining an image. And the image BG there, I'm not actually showing how that's done. It's a little bit complicated, but basically you're setting up like a cache of any image data so that it's like pre-compiled, and that way you're not like trying to load it on the fly. It's all ready to go, so it can be instantly displayed on the screen. So we've got that, and now we want to add our menu. So we've got our menu component, my menu component, real clever name there. And we're going to send it a list of our 3 different items we want to show up on that menu. So we've got new game, and then we have the action we want it to take when the user selects that. Then we have continue, which loads the last saved game, and then we have settings, which shows the settings menu. And then finally, we have this translate value, and this is sort of like how you position with Scenic. This is how you position it on the screen. And it's just like an XY value with the origin being in the top left. So we're saying here, all right, I want it 408 pixels in from the left, and then 580 pixels down. And this value is used all over the place. So there's a nice shorthand here where you can just do T, and you'll see this all over in your scenes when you're using Scenic. All right, so we've got our basic graph built, but there's a couple things we still need to do here. First, we want to define our state. Like all of your scenes in Scenic are going to have some sort of basic state. For your initial parent scene like this, it's always, well, usually a good idea to build a graph and have that in your state, and also to take your viewport, which will come in with your options at the top there. And that way you can refer to it every time something is updating in this scene. You'll be able to pull those out of state to be able to update the graph as needed. And then we'll just return an OK tuple with your state in there. And then we have the option there that's push graph, and that's going to tell, like our 3-layer cake, it's going to send that graph down through the viewport down to the driver so that it can actually display this scene that we've built. OK, so let's go check out demo real quick. To run, To run, you just do mix scenic.run. We're going to go ahead and load that up. And now, cool, so that is our game. We just have the Epic RPG is just part of the image itself because I wanted some cool pixely shadow on there. So we've got our rectangle right there with the image showing. And then we have our menu down at the bottom, which is taking my key commands. Yeah, woo! All right, so I'm going to go ahead and select new game. And what that's going to do, so I'm going to press enter, and the driver is taking that input, and it's passing it up through the viewport to the scene, and then the scene is actually sending a message back down to the viewport saying, set your root value to a whole new scene. And that's going to wipe this out, so this background will be gone, the image will be gone, the menu will be gone, and then we'll load a brand new scene. So we'll go ahead and start it up, and now we got this great world overview layer. We've got a little guy animating up here in the top left, and he's got a nice 2 frames, simple animation. But he actually turns, which is cool, left and right. And then we're going to go down here to this forest area and check that out. And now we got a nice local view. And here we've got a few more frames going on. So he's got 8 frames or something like that for his walk animation. When you stop, he stops and goes to that fun little dance in place idle animation. We have another character, or a couple characters. We have a sleeping little chicken up there. And then we have this bard playing her little guitar. So let's go ahead and go chat with her real quick. We're trying to add to our party. So say hello to her. Hey, I just met you, and this is crazy. But here's my party, so join it maybe. And after a little bit of reluctance, she says, OK. So now we have this hipster bard has now joined our party. We're going to go ahead and go up, check out the next screen. We've got some more chickens dancing around. And then we got some pirates waiting for us over here. So we're going to go ahead and interact with them. I'm going to give him a nice little insult. Hey, you fight like a dairy farmer. And he's going to say, how appropriate, you fight like a cow. And then that's going to go ahead and set us into battle and jump us into this kind of classic Final Fantasy style battle scene. We'll go ahead and queue up some fights here. So all 4 of our guys on the left. See, I have my menu down here. It's the same component we used earlier. The font size is different, so it fits down there. But we're going to go ahead and just queue up all 4 of these people are going to fight. And let's see. So it's real simple. I wanted to have them move out, but I didn't get to that. So there they are, just simple little attack moves, and takes out all the pirates. And that's it. That's the end of my cool E3 demo there. Let's go jump back. Thanks. All right, so let's go jump back into the code so we can see how some of that is actually working. Especially the animation, which was the hardest for me to figure out. When I first started doing this, I was looking forward to setting up my sprite sheet and animating through that, and Scenic does not support sprite sheets yet. Boyd, if you're listening, get on those sprite sheets, buddy. There's definitely a bunch of people that have been talking about it, and it's been discussed on the Elixir Slack channel in Scenic. So I think it's coming. Boyd has talked about kind of an alternate version, but whatever the answer is, we want those sprite sheets. But I've kind of worked around it for now. So let's go ahead and take a look at what we have. So this is for that like local town scene. So when you first show up inside the forest, this is our init function for that. And right at the top here, is that fitting? Yes, sweet, fits on the screen. So our first line here, we see scenic.sensor.register. And this is, it's an external package. It doesn't come with Scenic, but it's often used. That's called scenic.sensor. And this is what I've found to be the best way to send messages around two different scenes. There's like a nice, easy way to kind of bubble messages up from small scenes to the parent scene, but I found it kind of difficult to go the other way, and I found this package being kind of the best way to globally send messages around, and the components that care about it can subscribe and follow that. And the biggest problem with scenic.sensor is it has a terrible name, because when I first heard it, it sounded like, hey, if you have like, I don't know, like a radiation sensor or a temperature sensor more likely, or something like that, like, okay, cool, I can use this sensor package. But really, this is just a pub sub. And it's a really nice, simple pub sub that works great with Scenic. And actually, just yesterday, Boyd posted in the Scenic Slack and said, hey, what do you guys think of me renaming sensor to pub sub? We're like, yes, please. Because a lot of people, myself included, saw the name and avoided it for far too long, not knowing that it does what it does. So it's got like your three simple functions there. You can register a brand new ID, and then anyone that wants to see like what happens with that ID can subscribe to it, and then you can publish and send data to any of the subscribers. So let's go back to our init function for the town scene. So first we're going to register a sensor called action, and this is what I'm using to handle any sort of keyboard input. So if someone hits the enter key or someone does any of the arrow keys, I'm going to use this pub sub to send out the information to anyone that cares for it. Most likely the hero character that you're walking around, he's going to want to know every time you press or release an arrow key. And then our second one here, this is kind of where the magic for animation happens. We're going to send out frames so that we can keep a consistent frame rate so that the animation doesn't just go as fast as it can. It's going to follow a frame rate. And we have a timer here right under it that's going to send every 33 milliseconds, which is about 30 times every second. It's a little bit off. If you want to be precise, there's a timer library called microtimer, which is really nice because you can be super precise and actually match, exactly 60 frames per second or whatever. But here, this is good enough for us. We're going to just send out a little tick every single time we want there to be a new rendered frame on the screen. And then after that, we're going to build a graph. So again, we do the rectangle, which we then apply the background image, which in this case is the town. And then we can use graph.update to change that anytime we move to a different screen. And then we're going to put the bard in there. And we have a tuple for her where we're telling the character which class we want, the bard, which animation we want her to start with. So you saw she's just playing her little instrument there. And then we have an L for we want her on the screen facing to the left. And then we have the translate value to position her on the screen. And then right after that, we have the character who's a hero class. His default is the idle animation, and then he's facing to the right. And we're going to give him an ID just to make it easier to target him later, and then the translate value. Then we're going to set up our state. The same way we have the graph in the viewport, but now we're going to start our frame rate or our number of frames at 0, and then every time we get that tick message, we're going to update that. So we can just keep sending out the current frame number so that any component that cares about it can follow along with that and update as needed. And then finally, we'll do the OK tuple with the state and push that graph out. All right, so at the top here, this is further down in that same component, the same town component or scene. And we're going to do a handle info, and that's going to capture the tick. And then it's going to grab the current frame number out of the state. And then right at the top, we're going to publish that right there to frame. So anyone that's followed frame, which is our characters, anything that's animating, it's going to catch that frame count. and then we'll update the frame and the state, so that continues to go up. And then down at the bottom, we have what our character component looks like. And right at the top of our init function, it subscribes to those two things it cares about, the action and the frame. And then inside of the character, so right at the top, we have a handle info where it takes, so it's looking for, capturing the sensor data and then the data that it's looking for inside. So frame, which is the name of our sensor, and then the frame data, which is that running counter. And we, in like 16-bit animation, you don't actually want to render, you don't want to animate on every single frame because you don't have 30 frames for every second. It's usually more like something like 10 frames a second. It's kind of that slower, jilted, like that's sort of the style of pixel art, is to have a little bit slower animation. So we're just using pattern matching here to catch like 2 out of every 3 frames, just to, no reply, kill that, we don't care about that. And then for the ones we do care about, we're gonna grab the graph out of the state. So we're gonna define a new graph, so graph equals state.graph. And then we're gonna use the modify function to find our hero and update. You see in that rectangle, it goes down, it's updating all the stuff that's not changing, and then it has the line that starts with fill. And that we're gonna use a get fill data function, which takes the state, and our state is gonna be holding information like what's the current animation, is it idle or walk, and which frame of that have we currently been displaying. And then it'll just update that as going, and then we'll have a same sort of thing for when you're doing the arrow keys. So instead of capturing frame, it's gonna be the action. And so we'll have something that comes in that says, hey, they press the arrow key. Let's update the animation frame to be walk instead of idle. Let's make sure the character's facing to the right if you press the right key, or the right arrow, and facing the left if you press the left one, and so on. And then, oh, I'm doing way better than I thought. I got a couple minutes here, cool. Leisurely drink of water. All right, so that's how get fill data works. It's gonna just get that frame and update it, and then when you release the key, it'll send another message for that so that it knows to go back to the normal idle animation. And that is my talk. So thanks for coming, and if you have any questions about Scenic, I'd love to chat with you, or just game design at all. I had a blast doing this project. I don't know if Scenic is meant for games and if it will ever be like a great use case, but I had a blast doing it, and I recommend you giving it a try. Thanks.